So student, today we will discuss the form factor, which is a very important thing in the context of our quantum or microphysics. This is something related to the size of the particles or size of the system we are considering. So before going to the detail of the form factor, let us see what actually mathematically form factor means. Suppose for a charge distribution. Now charge distribution we discuss here particularly for the reason that we are discussing the nucleus. So we have the proton there, we are positively charged particle. So inside this nucleus, there is a distribution of charge. And due to the distribution of charge, so whenever you're considering distribution of charge, there is something like some dimension is coming into play that is actually related to the form factor. So there are different kind of form factor. So here we'll discuss the form factor which is related to the density distribution. So there may be magnetic form factor also and other kind of form factor. Now let us see what is form factor actually means mathematically. So if it is the rho r is the charge distribution, so Fourier transform of this describes the extension of the object in the momentum space. So here you see the form factor we are considering. It is actually the function coming as a function of momentum. So it is in the momentum space. So f q dot, it is the vector. That is the change of transfer of momentum, maybe qi minus qf. So this Fourier transform of this charge distribution is rho r e to the power iq dot r t r. Where fq, this fq is called the form factor of the particle. Now, fq square is response of the object when probed by projectile transferring a momentum q. So if a projectile is probed, a particle is say suffers scattering by some projectile, and the momentum transfer bq, so it is fq is the response of that momentum transfer. So so this is what actually physically form factor, by form factor we mean. But for let us first calculate what will be the form factor for a symmetrical charge distribution. So here you see we have considered a charge distribution rho, but rho is only a function of r, that is a spherical symmetric charge distribution. So the Fourier transform, as usual, we can write it this rho r e to the power iq dot r dq bar. And this elementary volume, everyone knows, all of us know, it should be like this. So if you go on with this integration, we actually arrive at this expression. So this is this expression. So now for in this subsequent steps, we have just made some substitution to get this to perform this integration. And which is very easy till it is written in this how we can proceed for doing the integration. And after that we come to this expression when we've done our integration over the angle theta and phi. So we are left with only all these functions with which is a function of r, and this is the expression 3 which gives us the what is the value of the structure function, form factor. Now for spherical symmetric charge, if we put the constraint that wavelength of electron is compared to the very large compared to the nucleus, so it is QR will be less than 1, so we can expand sin QR in terms in the expansion series. And with this expansion series, we can come to this this expression. Right? Yes. With this, taking only the first two terms and neglecting the other terms. So ultimately, we can write this whole expression 1 minus 1 by 6 q square and a square average. That a square average is replaced by this whole integration. and this A is called the mean square radius of charge distribution. So here we have learned about the mean square velocity distribution, all these things. So here it is a mean square radius of the charge distribution. It gives us a idea about the size of the charge distribution. So, for example, if you consider the Rutherford scattering, if you consider the point charge, the scattering cross section will be only this. But if you consider the distribution of charge, then it would be modified by the FQ square. So what is actually definition at the end we can come to? The form factor gives us the ratio by which scattering cross section is reduced when the charge is spread over a volume overall. So FQ can be determined sufficiently accurately by experiment. Because in the experiment we can FQ, if we can get the FQ, then looking at the expression, previous expression 3, we can get idea about the charge distribution inside the system. So to get an idea about the charge distribution, that is rho r and RMS radius of the charge distribution, the form factor is a very important tool for getting that idea. And as you say, whenever you consider charge particle having the is a assembled of some charges, so if you consider it a point particle, that's it's a different if the cross section will come. So correction to the cross section come due to the form factor, which is in other words is the radius of the distribution. It is something related to the distribution of the radius. So here we just write a figure like this, the transfer of momentum with angle theta. So this actually what form factor. The form factor is very important concept in the context of the microphysics we are talking about, because the particle size, the charge distribution, everything we have to find out indirectly from the experimental result. So if the form factor is known, because if you go to the previous slide, we can say that if you know the scattering cross section, which you can determine experimentally, and similarly we have all this quantity known to us experimentally, you can get the value of FQ square. That is what will be the form factor. So from the experimental value of form factor, we can find out what will be the kind of, this A value of A square, and get an idea what will be the value of rho r. So this is very important. Now in this slide, actually I have given some problems. Problems nothing but is that you have to find out the FQ square when their distribution is given. So rho r can be of different kind. We can assume different kind. So in this problem, you are given this distribution. Say what is, calculate what is form factor is. If the distribution is given by some exponential function minus b by r, go and calculate what will be value of the FQ square. Here the result is already given, so you just check it whether you got it. And here also we have given a Gaussian type of distribution, maximum distribution. So this kind of distribution, you can see what will be the value of FQ square is. So you can have idea that form factor is a very important property for a particle, or in our case, which we are discussing in the context of nucleus, which has some charge distribution. But you can apply this form. You can see if you go to the nets, you can see that there is a huge application of the form factor, or in other words, sometimes there is some called the structure function. So I will request you to go through the net and consult some books to see to get an idea how important this cross section, how important this concept is form factor.